Hey, hi guys, welcome back to my YouTube channel. As you guys are aware, I'm soon starting a Master NetDevOps training. So today I'm going to talk about one of the topics from it, which is Docker. Docker is quite famous these days. Everyone is talking about Docker here and there. However, most of the people are still not aware that what exactly the Docker is, how exactly Docker works, how exactly Docker is different from a virtual machine. Because we used to have virtualization since quite long, and Docker is also a virtualization technique. So why do we need this? What was the use case of it? Why we are moving from a legacy virtual machine to the Docker-based environment? So I'm trying to answer all these kind of queries today in this video. So without wasting time, let's get started. So first of all, what is Docker? Docker is a virtualization software. As we discussed, it's a virtualization technique. It makes the developing and deployment of application much easier. How it makes it much easier? Earlier, what was happening is your development team used to develop an application, whatever type of application, and that application obviously must be having some type of dependencies, some type of services are required, some type of tools are required for to run that application. So development team will club all these together, communicate that to your deployment team, which actually deploy those application into the servers. Okay. So obviously there are some artifacts, some dependencies, some services, some tools, some information which needs to be communicated from the development team to the deployment team, and deployment team needs to follow those instructions, need to follow the checklist, what needs to be done, what doesn't need to be done, and then based on that they will deploy that application onto the servers. So that was a legacy, that was a traditional way of doing it. What Docker brings to the table is Docker saying that all these dependencies, tools, services, your artifacts, checklist, everything can be clubbed together into one package. And that package is called Docker image. And then based on that Docker image, we will provide that Docker image to the deployment team, and deployment team straightforward needs to execute that Docker image and creates a container. And that container is a isolated virtualized environment for that particular application. I don't need to install any of these dependencies, services, tools on my base operating system which is installed into my servers, or deployment team doesn't need to take care about those. Okay, it package application with all the necessary dependencies, configuration, system tools, and the runtime. This information is packaged into this Docker image, and this Docker image is a portable image which needs to be ported from the deployment team to from the development team to the deployment team, and their job is to run that package. That's all, nothing else. Also, running that package, executing that package into a container is just one single command. That's all. They don't need to do anything else. And also when they are doing it, that command is same across all the different type of platforms. So whether they are installing it in Linux, whether they are installing in a Mac OS, whether they are installing into Windows, doesn't matter. It's just one single command that is required to convert that Docker image into the containers. Make sense? So moving forward, I was keep talking container, Docker. So first, let's understand how the development process looks like before the containerization, before this Docker container concept came into the picture. So development process before the container, each developer needs to install, configure all services directly on their OS on their local machine. So if I'm a developer, I'm developing some example, let's say Node.js application. I have to install all the dependencies, all the services, all the tools required to develop that application that will leverage the Node.js into my own machine. Okay, that's okay. That makes sense. I can do that. And I did all the development. Now I have given that information to the deployment team. Hey, I need this dependencies, these services, these tools, these runtime into the base OS, base operating system before this application is getting installed. Now, when it comes to the deployment team, they are managing many different type of infrastructure. They have Windows, they have Linux, they have others as well. Now, when they're installing it, first of all, managing those different services, different dependencies on a different operating system is a big deal. Okay. And there are many steps involved, and there are very high chances that one of them can go wrong. One or even more than that can go wrong. And in that case, team needs to go back to the development team, check where the exactly issue happened, what went wrong, and everything needs to be rechecked. So it's a long process. Okay. So we are just trying to overcome those hurdles, those issues when it comes to the communicating the application from the development team to the deployment team, or we can say operations team. Okay. Now let's see how the development looks like with the container, how the development process looks like with the container. So with the help of the container, you will have your own isolated environment, application packages with all dependencies and the config. This is what I was talking about. They packaged into something called a Docker image. It's not container, it's a Docker image. Okay, I will clarify those differences as well between them. Start services as a Docker container using one single command. Just you need to do Docker run and put your service name and it will be started. Commands are same for all the OS. Okay, and commands are same for all the services, irrespective of you are developing a Node.js service, you are developing some Redis service, you are developing some MongoDB service, doesn't matter. It's the same single command. So for a deployment and operations team, they actually doesn't need to care about what exactly the parameters you have used while developing your application, what all services you have used while developing your application. Since it's just one single command they need to care about, that's all. And they will be able to host that service into any environment, any operating system, any machine with just one single command. Sounds interesting, right? Let's move forward. Now let's talk about the main question for which we all are waiting for. Okay. What is the difference between the virtual machine and the Docker? Virtual machine versus Docker. Why is Docker so widely used? What are the advantages does it have over a virtual machine? And what are the differences? So let's understand that one by one. First of all, we need to understand what is an OS made of, how the operating system has been made of. Operating system has been made of with the help of hardware, OS kernel, and the OS application layer on top of it. Now, hardware and the application layer. Application is your OS. Okay. It might be a Windows application, it might be a Linux application, and the communication between the application and the hardware is being done by the kernel. If you guys are already aware of how the OS is being architectured, you guys may be well aware of this particular setup, how exactly this works. So I'm just giving you an overview. How does it looks like? So OS application, as I said, can be Windows, can be Linux, and the OS kernel's job is to make the communication between the hardware and the OS application. Okay. Now, what exactly we virtualize when it comes to the virtualization? Let's talk about first of all the legacy virtual machine. In virtual machine, we actually virtualize the OS kernel because we will be using some guest OS and the OS application layer, which is my kind of application. Okay, and they will be using same hardware. That's what we were virtualizing. Now, with the help of Docker, we have to just virtualize our application layer. We don't even need to virtualize the OS kernel. Why? Because there is no guest OS. So how the hierarchy looks like, you'll be having base OS. On top of that, you will be having guest OS. And then on top of that, you will be having app, your application running. So application obviously requires some of the kernel functionalities, which they will take from the guest OS. That was a legacy VM based setup. Now with the Docker, how exactly it will happen? So you will be having a base OS, and base OS obviously will be having a OS kernel. And then on top of it, you will just simulate your application. And if application requires some operating system kernel files or the kernel services, they will take it up from the base OS kernel itself. Means you don't need this middleman now. So we are just making it more lighter compared to the legacy, where we have to have a base OS, then on top of it, we need to have a guest OS, and then only our applications can be hosted on it. Sense? So this is how the architecture looks like. In case of virtual machine, you have your physical virtual machine, you have your host OS, and then on top of that, you will create some VMs using some sort of hypervisor like ESXi or KVM or whatever kind of Hyper-V, whatever kind of hypervisor it is. So first you will install one guest OS, either Linux or Windows, whatever it is. And then on top of it, you will host your application. Similarly, you will create multiple guest OS and multiple applications. However, in the base of containerized apps, you will have a virtual machine, you have your host OS, and you have a service called Docker, which is running on your host machine. And using that service, you can create multiple containers which host your applications. So we are basically absoluting this particular layer from the legacy to this containerized infrastructure. Make sense? Docker image is in size of megabytes. It's very lighter. Since we are not having guest OS, we are just having our service, our application which is running. So the file size is very low and it takes just seconds to start. How? Because it's a low in size. Obviously, it doesn't need to load the guest OS and then load the application on top of it. It just need to load the application. That's all. So instead of having a couple of minutes, now you will be having a couple of seconds to run it. Similarly, when it comes to the VM image is in the size of gigabytes, as we already know, because there is a guest OS associated with it. So OS itself is a huge file, and then top of it might be your application is very small. But since that application is hosted on that guest OS, we need that guest OS also. And VM takes minutes or sometime even hours, depends what type of guest OS we have, what type of application we are hosting on it. So that's majorly the difference between these two. But obviously there is some compatibility issue which may arise. Okay. Why? Because you have a, let's say for an example, you have a Windows hardware. On top of it, you have Windows OS kernel. And on top of it, you have Windows OS application layer. You came up with some Linux OS based application, which is your let's say Docker image. And then this Docker image, while you are installing it in a Windows OS kernel, obviously we all know that Linux OS kernel is different from a Windows OS kernel. So the application which is running on a Linux OS that cannot take the advantage of Windows OS kernel. So then there will be a dependency on the operating system, which we don't want. Okay. Because of this, this particular solution may not scale much. Okay, or people won't go with it. So that's why they come up with a solution called Docker Desktop App. Okay. You can install Docker Desktop App in your base OS in your machine. And that Docker Desktop app acts as a hypervisor layer with a lightweight Linux distro. It's a very lightweight Linux distro, which it will use. And if you either you are installing it in on a Mac OS, whether you are installing on a Linux or whether you are installing it on Windows, doesn't matter. When you are installing your app, and now that app is mostly the apps are Linux based distros. So or it's a Windows based, doesn't matter, because there is a thin layer in between, which is your Docker layer. And that Docker provides that Linux distro, which is compatible with most of the Docker images. So you are having a Docker image, which is based on some Linux, and your host OS or your main OS is Windows. So you will be having one layer of abstraction called a Linux distro. So when your Docker image needs that kernel files, obviously your Windows kernel won't be able to suffice that. So this particular thin layer in between will be able to serve that. Okay. So Docker image, as I said, consists of all your necessary files, necessary dependencies, services, tools, runtime, and it will get installed as a container. And that container is a complete isolated virtualized environment to run that particular application. And that container will be running on top of this Linux distro, a very lightweight Linux distro. So you guys can go and install the Docker desktop app and you'll be able to leverage that Linux distro and host your different type of apps, different types of services in a containerized environment into your own local machines. Okay. So I guess this is pretty much makes sense to you guys. Again, I'm just revisiting, I'm starting this Master NetDevOps class starting from 18th June. And there is a registration link which you can find in the description. And there is an introduction video which I will also mention in the description. If you guys have not watched it yet, you guys can go and watch it and you will get a clarity what exactly things we are going to learn. So these all DevOps stuff, NetOps stuff, network automation is something where my focus is. Okay. And I'm trying to put as much as information I can in front of you. Okay. So thank you for watching my video, guys, and don't forget to subscribe my channel. I will see you soon.